Hello, 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 everybody. I hope you're all doing well. We're looking now at question number 20 on our 2008 Fermat paper. In the diagram, LM is perpendicular to MN. It's almost like this is X and Y axes, almost. It might not be relevant, but let's see. So LM is perpendicular to MN, fine. Rectangle WXYZ has W on LM, Z on MN, and we know we've got 1 meter here and 3 meters, and we're told it's a rectangle. So that tells me I've got 3 here and 1 here. This is perpendicular. I might start thinking right angle triangles, 30, 60, 90, or not necessarily 30, 60. 30, 60, 90 was the last one, but Pythagorean triples, I might think. And so I notice we've got a 1.2 here, so this might be a 3.0. And is there some sort of triangle that I recognize there? Well, they both are multiples of 6. This is 2 times 6, and this is 5 times 6. So, I mean, it looks like there's going to be right angle triangles, but maybe not good ones. So maybe we won't actually need that. Anyways, MZ is 1.2. What is the distance from X to line MN? Okay. Now, if you go ahead and treat this as X and Y as the axes, you could say, well, Z has coordinates 1.20. And if you want the height, you just sort of, if you want the distance from X to MN, you just need the Y coordinate of X. I'm not going to do it that way, but I think that would be interesting to figure out the line ZW and then figure out the perpendicular line that also passes through W. The challenge then would be going a distance 1 along that line to get to X. Of course, you could figure out the line WX, you could figure out the line XY. It would take a while, but then their intersection point would have to be X. So there's possibilities here. I just think it'd be a little tricky figuring out Y to get the line. To get the line XY would be a little difficult as well. But, so, I mean, that's one way to do it, and I'm not discounting that as a possibility. I think there's probably a simpler way to do it with just triangles and similar triangles and angles and stuff like that, which might be why they didn't say, let this be the x-axis, let this be the y-axis. I don't know. Well, let's copy our picture down into our notebook so we can muck about with it. Alright, that's alright. I mean, the rectangle's a little bulgy, but it doesn't particularly matter. Nah, I'm going to redraw it, just because the X is further to the right than Z is. I keep drawing it way too steep. Alright, that seems a little better. Okay, here's W. We've got 3 here, 1.2. It's very interesting that they chose 1.2. We've got 1, 3, 1. We've got X up here, right angles abound. And we are asked for the distance from X to MN to the nearest hundredth of a meter. So if you didn't already have your calculator out, I would suggest you get it out. Okay. So what might we be able to do here? I want X downwards. That's going to make a nice right angle there. Now, if I were to chop it in half here and call the origin O, and we've got X, Y, W, X, Y, Z, I don't know, I'll call this point U down here. So, oh, no, that's not O, it's M. They actually gave it a name in the problem. M, N, L. Okay. So, so WM is going to be the same as UV. And WM is going to be, so WM squared plus 1.2 squared is equal to 3 squared. Now, I already remarked this is sort of 3.0, so this is WM squared plus 6 times 0.6 times 2, let's say. Trying to do as much of this as I can without a calculator. 0.6 times 2 squared is 0.6 times 5 squared. So 5 squared is 25, 2 squared is 4, so this should be, WM should be 0.6 times root 21. Okay, so I know that distance. That's not a number I know off the top of my head, and I would need a calculator to work it out. I could probably do a little guess and check, but let's not worry about that. Okay. So I've got WM. Fine, fantastic. But how can I figure out XV? Because we want UX is UV plus VX, and that's going to be WM plus VX. I have no idea what VX is. I think we're going to have some similar triangles here. So, no, let's not use blue. Let's use orange. So, this angle here, dot. And this angle here, check. So, we've got right angles here. So, that means this also has to be dot. But this is a right angle. So, this is going to be check. And this is a right angle. So, this is dot. So, they're in the same ratio. So 1.2, 0.6 times root 21, 3. So it's the 5, 2, and root 21 triangle. But now we've got it with 1 here, so we should have 2/5 and root 21 over 5. This is technically the 3/5. 0.6 is 3/5. Alright, so I know it's 1. So which thing's opposite the check? The root 2 is opposite the check mark. So this is the root 2. So this is going to be, not root 2, 1.2. My brain is making the connections. I'm just not saying the words right, which is a problem because this is a video for you, not for me. So the check mark is opposite the 1.2. So here's the check mark. So this is the 1.2 ratio side. So that's going to be the 2 over 5, or 0.4. So this is going to be 0.6 root 21 plus 0.4, which is 2/5. And now I'm at a stage where I can just grab my calculator. So we'll do square root 21 times 0.6. Which I'm getting 2.749. So 2.749, and then we want to add on 0.4. So I'm getting about 3.14. Nifty. 3.1495. So let's round up because they wanted to the nearest hundredth, so 3.15. It's going to be my final answer. Is that one of the possibilities? Yes, it's the one that I've sort of drawn a line through. It's C. So that shall be my answer. And that does it for question number 20. So we'll be starting questions 21 through 25 in the next sort of set of videos. I would encourage you strongly, if you have not already done so, to download a copy of the contest. Try those questions out before watching further. Practice the questions. Don't just watch me go through them unless you're really, really stuck. But try them out. See if you can, get some of the cases or work partway through the solution or get some of the lengths of the triangle. I don't know what the questions are yet. But see if you can just make it partway through some of the question. Okay? So that's question 20. I will see you guys in the next video for question 21.